This is Pre-Calculus Section 3.2 Notes, Day 1. Today we're going to begin by talking about dividing polynomials. And in order to do that, we're going to review a little bit about what you know of long division. So first, let's review what you learned in elementary school. If you were going to divide a number like 367 by 5, first you'd ask yourself, does 5 go into 3? The answer is no. So then you'd take it one step further and say, does 5 go into 36? Yes, it does. 7 times. So you'd write a 7 above the 6. And then 5 times 7 is 35. So you'd write it underneath. And then you would subtract. 36 minus 35 is 1. You'd bring down the 7. And then you'd repeat this process. Does 5 go into 17? Yes, it does. 3 times. So you'd write the 3 above. You'd multiply 3 times 5, which is 15, and then you'd subtract. 17 minus 15 is 2. So in the beginning days, you'd stop at that point and you'd say, well, I have a remainder of 2. And then perhaps when you got a little bit more sophisticated, you might write your answer as 73 and 2/5, or 73.4. Now when we're doing long division, or any kind of division really, it's easy for us to check our answer. We can check our answer by multiplication. So if we took 73.4 and we multiply it times 5, we should get back to where we started, which is 367. So we know that we did it right. Well, now we're going to do the same process, but with algebraic expressions, specifically with polynomials. So let's start with 8x squared plus 5x minus 6 divided by x plus 3. So our divisor is the polynomial x plus 3. That is going to go on the outside. And our dividend is 8x squared plus 5x minus 6. Okay, so we start the same way, but we're going to look at the x, and we're going to look at the 8x squared. So the first term in the divisor and the first term in the dividend. And the question we ask is, what would we have to multiply x by to make 8x squared? The answer, of course, is 8x. So we're going to write that on the top, but we're going to write it above the x term. It goes above its like term. And now we do the same thing that we did with numbers. We multiply what we put on top by what's on the side. So we're going to multiply 8x times x. That's our 8x squared. And then we're going to multiply 8x times positive 3, which gives us 24x. Now here's the key to the whole problem. We don't subtract when we're working with polynomials. Instead, we say that we are going to draw the line and change the signs. So since these are both positive, they both become negative. And then instead of saying we're subtracting, we're going to be adding the opposite. So our 8x squareds are going to cancel out. We have a positive 5x plus a negative 24x. So that's going to give us a negative 19x. And then we're going to bring down our constant term, which is negative 6. So now we have to repeat this process one more time. So now we are looking right here at the x and right here at the negative 19x. And we say, what would we have to multiply x by to make negative 19x? Well, that's going to be negative 19. So then we multiply negative 19 times x. We get our negative 19x. Negative 19 times 3 is going to give us negative 57. But once again, now we're not going to subtract. Instead, we're going to draw the line and change the signs. So since these are both negative, now they're both going to become positive, and we're going to add. The x terms cancel, and then we have negative 6 plus 57, which gives us a remainder of 51. And just like with numbers, we can write our remainder over our divisor, like that. So here is the answer to this division problem. Let's look at another example. This second one is a bit more complicated. The first thing I want to point out is that our divisor is missing a term. It goes 3x squared minus 2x cubed. We don't have an x squared. Okay, so right here we are missing a 0x squared, or we need to add in, I should say, or hold the place with a 0, and then we have x and 4. Our divisor goes x squared, x constant, so that's fine. So we're going to set this up the same way. We're going to put our x squared minus 3x plus 1, that's our divisor, on the outside of the bar. And underneath the bar, we're going to put our dividend, which is 3x to the 4th minus 2x cubed plus 0x squared plus x plus 4. This one's going to be kind of a long one because we've got a lot of terms. This isn't hard. It just takes some patience and some good bookkeeping. Okay, we're going to start out this problem exactly the way we did before. We're going to look at our first term here and our first term here and say, what would we have to multiply x squared by to make 3x to the 4th? The answer is we'd have to multiply it by 3x squared. So we're going to write that above the bar over its like term. So we're going to put that 3x squared right there above our 0x squared term that we added in. And now we're going to multiply. Now when we multiply the 3x squared, we're going to multiply it times all three terms in the divisor, write it underneath, and then draw the line and change the signs, just like before. So 3x squared times x squared gives us 3x to the 4th. 3x squared times negative 3x gives us negative 9x cubed. And then 3x squared times positive 1 gives us 3x squared. Okay, now we're going to draw the line and change the signs. So this becomes negative and positive and negative. And now we go ahead and we add our like terms. So those cancel. Negative 2x cubed plus 9x cubed gives us 7x cubed. 0x squared plus negative 3x squared is negative 3x squared. And we're going to bring down the next term, which is positive x. And now we're going to repeat this process again. We're going to look at the x squared and the 7x cubed. And we're going to say, what would you have to multiply x squared by to make 7x cubed? The answer is a positive 7x. So now we're going to go ahead and do that multiplication. 7x times x squared is 7x cubed. 7x times negative 3x is negative 21x squared. And 7x times 1 is 7x. Now we're going to go ahead and draw the line and change the signs. Negative, positive, and negative. And we're going to add. Our x cubeds cancel. Negative 3x squared plus 21 is going to give us 18x squared. And positive 1x minus 7x is going to give us negative 6x. Now we're going to bring down the plus 4, which means that we have to do this cycle one more time. So we're going to look at the x squared and the 18x squared. And what would we have to multiply x squared by to make 18x squared? Well, that would be 18. 18 times x squared is 18x squared. 18 times negative 3x is going to be negative 54x. And then 18 times 1 is going to be 18. And now we're going to draw the line and change the signs. So this becomes negative. This becomes positive, and this becomes negative. Our x squareds cancel. Positive 54x minus 6x is going to be a positive 48x. And then positive 4 plus negative 18 is going to give us negative 14. So that whole thing, 48x minus 14, is our remainder. So let's see if we can squish this in over here. So we're going to write plus 48x minus 14 over our divisor, which was x squared minus 3x plus 1. And this right here is our solution. The second type of polynomial division that we're going to talk about today is synthetic division. You may remember this from Algebra 2, but there's one really important thing about synthetic division that you have to remember, and that's this can only be used when the divisor is linear. So meaning you have to have x minus c as your divisor, okay? And again, just like with when you do long division with polynomials, you have to hold the place of any missing terms with zeros. Very important. If you don't do that, things are not going to work out the way they should. Okay, so for our first example here, x squared plus 7x plus 10 divided by x plus 3. The one thing here that we have to think about is if we're dividing by x plus 3, then the value of c is actually the solution to that factor x plus 3. The solution to that factor, or what we call our c value, is going to be -3. Okay, and hopefully this is going to ring some bells here once I show you this example. So we're going to draw what appears to be kind of an upside down fraction bar. We're going to put the coefficients of our polynomial across the top, but we're going to leave an empty row underneath. So we're going to write 1, 7, and 10, but we're going to leave that space underneath. And then we're going to put our c value outside the bar right here. Okay, now we're going to bring down our first term, drop it below the line. And then this is just a series of multiplication and addition. So we're going to do -3 times 1, which is -3, and we're going to write that below the 7. And now we're going to add. 7 plus -3 is 4. Then we're going to multiply -3 times 4, which is -12. We're going to write that below the 10, and then we're going to add. 10 plus -12 is -2. And when we get to the end, like we just did, then basically we just have to write our answer in polynomial form. So starting from the furthest right, this is always going to be your remainder, and then your constant term, and then your x term. So our answer here would be x plus 4, and then our remainder would be -2 over x plus 3, because that was our divisor. Let's try a second example. This polynomial is a little bit longer, and please note that we are missing an x cubed term. So we're going to need to put a 0 in that spot to hold the place for the x cubed term. We are dividing by a linear factor. The factor, or the divisor, is x minus 2, which means that our c value is going to be +2. So we're going to draw our upside down fraction bar. We're going to put our coefficients across the top. 1x to the 4th, 0x cubed, -2x squared, 6x, and -5. We're going to put our c value, +2, outside the bar. We're going to drop down our first number, which is a 1, and now multiply, write it, and add. Multiply, write it, and add. 2 times 1 is 2. 0 plus 2 is 2. 2 times 2 is 4. -2 plus 4 is 2. 2 times 2 is 4. 6 plus 4 is 10. 2 times 10 is 20. And -5 plus 20 is +15. And then again, from right to left, we have remainder, constant, x, x squared, and x cubed. So our answer here is going to be 1x cubed plus 2x squared plus 2x plus 10. And then our remainder is 15 over x minus 2. Please note that because when you're doing synthetic division, you're always dividing by a linear factor, the polynomial that you get as your solution should always be 1 degree lower than the polynomial that we started with. So when we look at this particular problem that we just did, we started with a polynomial that was a 4th degree, and we ended with a polynomial that was 3rd degree. When you're doing synthetic division, if you do it correctly, that should always be the case when you are finished.